Hello, my darlings. Okay, so today we're going to talk about the average value of a function. Now, before we talk about that, just think about it. How do you take the average of n numbers, right? You would add them up and divide by the number of numbers, which in this case would be n. So you would divide by n, right? Okay, so that's easy enough. So for a function with infinite values, we start the same way, okay? We sum up the function values of f of x and divide by n. So this is the part that tells us to add them up, and this is the part that tells us to divide by n. Now this looks familiar, but it's not quite the format of the definite integral. We want to fit the format of the definite integral. What's missing? The piece that's missing is the delta x. Now remember, delta x is b minus a over n. Well, we have the over n part right here. What we don't have is this b minus a. Now we can't just stick it in there. But what we can do is we can multiply by b minus a over b minus a, because that's really 1, right? So if we take that initial summation as k goes from 1 to n of f of x sub k times 1 over n, and now we're going to multiply it by b minus a over b minus a. Now we're going to simplify. Now that b minus a is really not affected by the summation because k is changing from 1 to n, so I can factor the 1 over b minus a out of the summation and leave that as k goes from 1 to n of our f of x sub k times b minus a all over n, right? And then that's the same as 1 over b minus a times the summation as k goes from 1 to n of f of x sub k, but that b minus a over n is just our delta x. Now, as we let n go to infinity, this becomes 1 over b minus a times the limit as n heads to infinity. And again, the b minus a can come outside the limit because it's a constant as far as n is concerned. The limit of that summation as k goes from 1 to n of f of x sub k times delta x, which is just 1 over b minus a. But remember, all of this is our integral from a to b of f of x dx. So now you know that if f is integrable on the closed interval from a to b, then its average value or its mean value on that interval is 1 over b minus a times the integral from a to b of f of x dx. And that's a real important rule. That's one of those that, yeah, unfortunately you have to know. I know I don't tell you to memorize too much. That's one you got to memorize, okay? Now, the mean value theorem for integrals, another way to say this, if f is continuous on the closed interval, then at some point c in that closed interval, the function value at c has to equal the average value. It has to happen because if it's continuous, just like the intermediate value theorem, if the function is continuous, it has to take on all the values in between, which means the average value has to be achieved at some point. Now we can prove this theorem, okay? Remember our properties from integrals. We had the max-min inequality, which said that the integral from a to b of f of x dx is trapped between the minimum of f times the length of the interval b minus a and the maximum of f times the length of the interval b minus a. Now if I divide each part by b minus a, that's going to leave me with the minimum of f is less than or equal to 1 over b minus a times the integral from a to b of f of x dx, which is less than or equal to the maximum of f, okay? And therefore, since f is integrable, that means f is continuous on the closed interval from a to b, and that means that by the intermediate value theorem, f of x must take on every value between the minimum of f and the maximum of f. So there must be a c such that a is less than c is less than b, and f of c equals 1 over b minus a times the integral from a to b of f of x dx. There you go. Okay, so let's take a look at an example. We're going to find the average value of f of x equals the absolute value of x on the closed interval from 1 to 2. Now think about this function. This is the absolute value curve. From 0 to 2, it's really just the line y equals x, right? Over here, from 0 down to 2. So the height here is 2, because this is the point 2, 2. And the length here is also 2. So our average value is 1 over, remember this is the a, this is the b. So b minus a is 2 minus 0 times the integral from 0 to 2 of the absolute value of x dx. Well, we have 1/2. Now the integral, we would find the area under the curve above the x-axis. That's going to be a triangle, and the area of a triangle is 1/2, the base is 2, the height is 2. All of this comes out to be 1. Okay, now we're going to find the c to satisfy the mean value theorem. So what we're looking for is the c whose function value is the same as the average value of f. In other words, the absolute value of c equals the average value of 1. Well, what has an absolute value of 1? That could be plus or minus 1. However, based on our interval, c would have to be 1 since the domain is only from 0 to 2. Okay? Now, what does it mean that the average value of 1 is? What it means is, if you find the rectangle here that has a height of 1, notice the height here is 1, and it's happening at this c value 1. That's your c, okay? This is the average value. If you find the area of this rectangle, it's going to be the same as the area under the curve but above the x-axis. It's the same as the value of the definite integral. So an average value suggests an average height. It's a y value. It's a function value. Okay? But it also means that the rectangle with height 1, which is the average value, has the same area as the value of the definite integral. How cool is that? Okay, kind of cool. Okay, one more example. Let's find the average value of f of x equals 6x squared minus x cubed on the interval between its x-intercepts. So the first thing is we need to find its x-intercepts. So to do that, we're going to take 6x squared minus x cubed, and we're going to set it equal to 0. I'm going to factor out the common x squared, which will leave me with 6 minus x equals 0. So my x-intercepts are 0 and 6. So that means we're looking for the average value on the interval from 0 to 6. So my a is 0 and my b is 6. So my average value of f is 1 over 6 minus 0 times the integral from 0 to 6 of 6x squared minus x cubed dx equals 1 over 6. Now we're going to go to our TI Inspire, and we're going to get that value, okay? Okay, guys, so here we are on our calculator page. Let's just do the integral first. We're going to go to our template key. Here's our integral. We're going from 0 tab to 6 tab. Our function is 6x squared minus x raised to the third tab dx. And we hit enter, and the value of the integral is 108. Now, to find the average value, we're going to multiply that times the fraction 1 over 6, and our average value is 18. There we go. Okay, so now we're going to sketch what this average value means. So we're going to find where the height is 18, and we're going from the interval from 0 to 6. Now this rectangle has the same area as the definite integral. That's what it means, that the area of this rectangle is 108. That's the definite integral. So notice it's equal to the value of the definite integral, okay? Not the average value. At this average value is the height of the rectangle that has the same area as the value of the definite integral, okay? That's what that means. Now, next part. Show that the average value does not equal the average of the two values of f of x at the endpoints. Well, first of all, we know that the average value is 18. If we find the average of the two values, that would be f of 0 plus f of 6 all over 2. Now remember, we just found that 0 and 6 were the roots, which means that f of 0 is 0 and f of 6 is 0, which means that their average is 0. Are these numbers the same? Heck no. 18 does not equal 0. We're done. All right, guys, so that's how average value works. So when you're finding the average value of a function on the closed interval from a to b, that's 1 over b minus a times the integral from a to b of f of x dx. Have a great day.